bližšie, jak to vlastne v tých mobilných telefónoch funguje z tej hardwareovej stránky, ako vyslovene z takého nadhľadu hardwareového. Nebudeme zachádzať do nejakých hlbších rozoberaní alebo do nejakých hlbších teórií, ako kde, pretože je to fakt v dnešnej dobe ako toho rozmachu mobilnej komunikácie a mobilných telefónov je to veľmi rozmanité a v podstate vždycky sa jedná len o ten základný princíp, ako to ten výrobca alebo ako to ten dizajner alebo inžinier navrhol. Takže bude to vyslovene len taká obecné oboznámenie v podstate, s čím sa môžeme stretnúť v tých mobilných telefónoch v dnešnej dobe. Ja osobne mám skúsenosti s opravami mobilných telefónov konkrétne. Opravujem mobilné telefóny značky Nokia, ale aj iné značky. Už skoro 7 rokov. Takže myslím si, že mám za ten čas nazbieraných dosť skúseností, s ktorými by som sa rád podelil s vami ako s hackermi, alebo aj keď nie hackeri, alebo dajme tomu programátori, ktorí programujú aplikácie pre mobilné telefóny. So I think we can switch in English? Okay, so hello. So, for the newcomers, I speak about that it will be only overhead over the problematics around mobile phones and hardware inside. It will be no detailed explanation because each vendor and each producer handles this kind of stuff by themselves. So the designer-related issues will be out of this presentation because it's really each slide can be for 2 or 3 hours in each. So it will be we can go to the next slide. First. Also, I want to talk to say that now I'm in Prague and I'm now a member of Brno Hackerspace, and we have many of I hope interesting hardware-related projects which can be also discussed by myself if you see me hanging around and so on. So feel free to speak, and if you are interested, after this talk, I hope we will have some 3 minutes to questions, but also is no problem. I have some samples, some scrap phones, so I can explain it directly on a direct board on the phone, so feel free to contact me. So the next slide, safety first. What kind of safety? Of course, phone can cause injuries to the humans, but this is opposite relation. This is what kind of injury we can do to the mobile phones. This is how to say basics of electrostatic discharge and problems about this and some. This slide can be explained for about 6 hours of talk because this is really science. How to protect and how to measure it and how to define it and so on. The basic things what we can meet in mobile phones is the passive protection. It's spark gaps, which is really close gaps between a grounding plate or grounding in a PCB and some signal wires. And if some electrostatic discharge is applied or is on the signal wire, the fastest route of the electricity is to go to the ground, yes? So the fastest way is to go to this grounding gap, and you can see here is some spark which calls that this electrostatic discharge is grounded. So this can be very helpful or this is very helpful if we have this signal wire directly connected to some special component or very how to say not cheap components. Yes, we need to protect the components at all. Also, if the design rules are not applicable to Spark Gap because they are quite big and quite huge, so we can use the active filters, which are some kind of BGA components, and they are ESD filters, named ESD filters. It's from 2 channels. This like small components to 12, 15 channels, and so on, so on. So it's really depends on the manufacturer and on the usage, concrete usage. So this is how it looks inside the ESD filter. It's normal diac, or how to say it, component, which is in a concrete voltage. There are no current in open way, but if this voltage is over this nominal voltage, the current goes very high, and this happens on both directions. So this part can easily hand some over voltage protection. This is also used in over voltage protection. These condensators and the resistor are for some remaining noise and higher harmonic filtration. So in our service department, we mainly use this ESD strap with grounding wire. We are really grounding ourselves. This strap is on our neck, and through the 1 mega ohm resistor we are really grounded. So this is really active and cheap and easy solution how to ground yourself. And if you are grounded, that means that you have a really small potential electrical, or your electrical potential is on around 0 volts. So you can be safe that you cannot damage by yourself any other components. And this is the ionizer gun. Top Gun say this is this functional. This function, how to say, this is equipment to use when you need to blow some dirt or something from the board. You need to use ionized air, because if you blow on with not ionized air, you can make some little storm like over the board, because board is also charged independently on each corner, how to say, and you can really smash some components. Yes, of course, this is the most how to say tragical or really extreme conditions. So this also is a matter of money. Yes, if we have really cheap components, we can avoid ESD protection. And if it's really cheap, you only change the board and doesn't take care. But if something goes wrong and it's a design-related issue, you can imagine what kind of damage you can make to your devices. So this is really interesting, and this is really a huge part of mobile phones. How to say, safety against people. So mobile phones itself. This is how it's said on the customer side. Yes, it have speaker, button, blah blah blah, nice covers. It's shiny, it's bling bling. Okay, so this is not what we are interested in. We are interested in engineered use. So this is like internal blocks of mobile phones, which we have some user interface. Yes, this interface interacts with user, which is displays, keyboards, and so on. We will go later on. We have CPU with DSP, which is the main stack of the GSM. Here is programmed. We have some power management because the CPU and the RF part and so on, they need some power to distribute from batteries and so on. And there are some special requirements. So,
sorry, what is the DSP?
DSP is digital signal processor. It is really a special designed processor to be really fast for some special purposes.
Alright, so it's like the graphic chip but it's for another purpose. But
Yes,
it's
yes,
for
yes.
speeding up the CPU.
Yes, exactly. The GPU can be really slow for some other computing,
Yes.
but for the graphical related and floating point operation and so on,
Yeah.
they can be really fast.
Uh-huh.
And this also happened in mobile phone, but here is especially for modulation and demodulation.
And so
purposes.
is there some cryptographic application of it?
Yes.
Like for example, they use GPU to crack passwords or to calculate rainbow tables and this kind of stuff. Is there something similar that you can do with the mobile phone's DSP? Like for example, I don't know, when somebody is jamming the signal and so.
Go to that
Okay.
slide later. I can explain, and this is really. I will explain it later.
Yeah, go on. Sorry.
So, yes, keyboard. If someone knows how the matrix keyboard works, it's totally the same. You have some rows and columns, and if they are multiplexed between, and if some key is pressed, the processor, the CPU can handle this interrupt and can say to the software, hey, number 1 is pressed, write number 1 to the display, or something like that. It's nothing. It's similar to the keyboard on computer. It's not nothing special. Displays is really one of the second, or how to say, I think it's the second part or most difficult part in mobile phones, and we can say that the displays are only modules. Display cannot be repaired, cannot be manufactured by ourselves, but we can use it. Some displays from old Nokia, some old Siemens, and so on can be reused for some hacker-related things. So we can connect it to the Arduino or some our test boards. So we know the protocol. It's a typically serial interfaced protocol. So it's very interesting because you can take these displays from scratch walls for really interesting prices. Yes.
But you cannot produce it, no?
No, it's not repairable. So during my work as a service technician, some guys told me that, oh, it's only glass broken. Can you only change that glass? No, it's not really. It's not possible to change the glass on the display when it's broken, because there are some liquid crystals under this, and they have some precise structure, and if you broke it, it's totally broken, and you cannot repair it. It's smashed.
But you cannot produce it because you haven't. It's expensive, or this is a special technique that.
Yes, it's special technique which cannot be, for now, cannot be reproduced in how to say, in a simple laboratory, which hackerspaces and hackers can. Maybe some. I have some infos that some organic displays can be made, which is an electro-organic base, but it's really simple. It's displays. So, but I think one day we will be able to also produce. But for now, it's only usable as a module. Yes. touchscreen. We have. This is really interesting of the last few years that mobile phones with touchscreen are really cool and so on. But we have two types, most common types of touchscreen, which are capacitive and resistive. They are practically do the same, but in one way we have a foil which, when we press, we can measure the axis. Each axis has a different resistance, and if we measure the resistance between the axis 1 and yes, so we have the one axis, and the corners of the other axis we can measure the value of the second axis. So we can exactly know where the customer is touching. This is the capacitive. This is the switching current, or how to say it, and we are measuring current through the display, and the capacitor is our hand to the ground. So this is really interesting, and this type of measurement can enables us to make some multi-touch and some cool stuff, because if we apply different capacitor in this circuit, we can measure 3 or 5 points, and we can exactly know where is the touching point. Yes, and also we don't need foil. We can only measure it on the glass, on a small piece of glass. So it's very comfortable, and I think more reliable for production. But they are quite expensive. Buttons. You know, I don't have some. Maybe this we can use this picture for buttons. Yes, it's normally totally normal buttons. What is really interesting, we have some autofocus buttons, which are 2 or 3 state buttons, and we can press it like twice, that button. We can press it once. This is the autofocus state. The camera focus it, and after the another more press, the camera shuts. It's similar to the keyboard yes, it's similar to keyboard connection, but I use it. I have mentioned it so it's nothing special. Connectors are really interesting, because in last days we have every small mobile has his own connectors and own chargers and so on. Now the European Union decided the micro USB is that right connector. I think it's very good, and we can share chargers to each other and so on. If you can see, we have only maybe 5 to 6 pins, which is solderable. So this kind of connectors can be really easily changed, and if something is going wrong with this connector, it's no problem to change it. If we have 20 pins or more, it's really hard to change those connectors. This is really good point for the European Union. Accelerometers. This is also part of the user interface, which we can in modern phones. I think every modern phone have accelerometer, but I want to say that the first accelerometers was not used to interact like user interface. It was done later, because the first usage of the accelerometer was for some special phone which have hard drives inside. Really, actually hard drives which are spinning, and this accelerometer was used to detect the free fall. Yes, when the phone was dropping, the accelerometer detects the free fall, generates the interrupt to the processor, and processor can hang on the hard drives, and when the phone drops down to the ground, the hard drive was never spinning anymore, and everything was safe. So after that, they recognized that, oh, we have accelerometer there. We can make some cool stuff with like changing songs. When you shake the phone, you are changing the songs and so on. So you can rotate the display. You can detect if you are taking photo in horizontal or vertical. Everything is done by accelerometer. It's actually knows the position of the phone. It's very interesting thing. It's and it's functional like we have some pads in a jelly. Inside is small ball, and this jelly is or this ball is taken to the ground by gravity, or how to explain it. And if how we rotate the accelerometer or this device itself, this ball is coming closer to these pads, and there is this is changing the capacity of this jelly ball instead of opposite pad. So it can be very accurate, really very accurate. Accelerometers are and really fast. Accelerometers in normal mobile phones they are used, I think 400 measures per second.
Wow.
It's really fast. It's connected via serial interface, I2C or SPI, and you can easily desolder it or buy it by itself, but they are really small, as you can see. It's really small. Okay.
Do you know how much is it? In money, if you want to buy one accelerometer?
I think around 30 bucks.
Mm-hmm.
It depends, because you can I think SparkFun have some modules really prepared for breadboard connection, and
4,000 hours space for playing.
what?
I have 4,000 hours space for playing.
Yes, they are not so expensive. I think maybe 30 bucks is enough, but
Even
if you are really interested, it's acceptable. And it's really fun to play with that. If you are interacting for some VJing or something like that, it's really nice. But they are also used in mobile phones. Another way is approximation sensor. Approximation sensor is really interesting, and approximation sensors are closely related to touchscreen devices. And why it is? Because if we have touchscreen, we need to detect approximation of something to the display. So if I make call and I place the phone to my ear, I need to detect it, because with my ear I can touch something on the display, and during the call the display need to be disabled when something is close to approximation sensor. Yes, because after that you can press the phone and you can close your or shut down your voice call or something like that. And also, if you have it on your pocket and someone is ringing to you can how to say, you can answer the phone even if you know about that. But you have approximation sensor, and an approximation sensor tells to the software that, hey, this phone is in pocket. Please don't answer that call, even if the phone is not away from that. Yes. So this is really interesting and really cheap part, I think. This approximation sensors cost these sharp sensors about $10, I think, and it can be used, for example, for robots and something. Of course, in the mobile phones they are really small and you cannot. They can be also brought with like modules, but this sharp is the same principle and not so expensive. ALS sensor, you can see they are even smaller than approximations the sensors in mobile phones. And what this ALS sensor means? It's ambient light sensor. This sensor take care about surrounding light. So if I'm in the dark room, I need to backlight my display more or less, but keyboard need to be backlighted more. And this is the decision of the ALS sensor. Because when I'm outside and there is a shiny, I don't need to backlight the keyboard, and the battery is not draining so fast. So this is also interesting part which can be found in mobile phones. And most of them are really calibrated, and they have digital output. So the light intensity can be taken really by digital output. So you don't need to recalibrate it and so on and so on. It's perfectly calibrated. Very interesting part. But they are really small.
Bilder.
Hello?
Okay, another part of the mobile phones are power management. Power management is really also one time which can be for a few hours, because it's also quite of magic and interesting things there are happening, which can be, each one can be explained for a few hours. So voltage regulators, this is the part of the schematics of some phone. Each part of the phone needs different voltages. So you can see we have voltages from 1.35 volts for maybe for SIM cards, and or 1.8 volts for some other type of SIM cards. We have some auxiliary voltages for some other parts, and 4.7 voltage, which most of the modern phones are connected to 3.7 voltage batteries. So this is the charge pump. This is the output from the charge pump, which makes higher voltage. So this is the VCP, charge pump capacitor. So this is really the basic of power management in mobile phones. This is the charging circuit. Yes, we have here the fuse, which is normal fuse as we have in our. We have some coils to avoid some peaks, voltage peaks from the mains. This is also the how to say safety fuse. This is the Zener diode, and this is the input of the charging circuit. We have the AD and DA converters. This is also part of the power management, because as we will talk later, the processors are really digital parts. So something need to handle that analog to digital. Yes, signal from the microphone is totally analog, need to be converted to some digital values, and after that need to be processed by processor. So, and also the ringing tones and some speakers and so on need to be DA converted, because from the network we have digital data and DA converters are inside. We have power amplifier to amplify it to the values which we can hear through this speaker. Yes. Another part of the power management is RTC, is real-time clock, and it's used for clock reference and the control or this is RTC clock. It's 32 kilohertz signal, classical quartz signal, and it's used in many other digital chips around the mobile for a reference. This is really interesting because if small part like this is actually maybe 1 millimeter to 1 millimeter part, and if this fails, the whole phone is broken and cannot turn it on, and it's totally broken. This is really interesting. We have also power of inside the power management. We have also watchdogs. The watchdogs are similar to watchdog on computers. The watchdog is watching for the voltage regulators, for the battery temperature. When the phone is charging and the battery goes really high, it can shut down the whole phone and the whole process can be stopped. That phone cannot make some injuries to us. It also watches clocks on buses, and it's really like a hardware hypervisor, or how to say it, through the all phone stuff. And also is watching clock references if something goes bad, and really can cause some malfunctions. Watchdogs is restarting the whole phone or shutting down the phone. We have also the PWM and PCM. PWM is to control vibramotors and spinning of vibramotors. Yes, of course, as I said, advanced light sensor goes to makes informations about surrounding lights. So we can control backlight and some signalless. Maybe you know some old Ericsson have that green LED always blinking. And also Bluetooth audio is transferred from power management IC by PCM. It's pulse code modulation. It's used in a really old mobile, not mobile, but really old phones. And the audio to the Bluetooth module is transferred by this. It's really interesting because it's really old technology, but it's functional. Okay, this is the whole schematics of the power management IC. As you can see, it's really hard to know or how to find something. Yes, we have here thermistor for the battery temperature, 32 kilohertz crystal for the real-time clock. This is the audio part, this is the microphone part, this is the voltage regulators. Here we have vibramotors, and so on and so on. So it's really hard to find if something sucks in this. It's really hard to. This is the backup battery for the real-time clock. It's quite interesting, and this is only the power management IC. If someone is interested, I can show the schematics of the whole phone, and it's really hard schematics. This is the power button, for example. It goes directly to the power management IC. Okay, here we have that CPU and DSP. For the CPU is classical. CPU is mainly based on the ARM core or something like that. We can have a single core and double core. I can say it. If we have some, for example, old Nokia's used two separate processors. One was for GSM stack, and another one was for the Symbian operating system. In nowadays, they are all stacked. So that means that they are on package. There are two processors on the top of each other. And it cannot be only two, it can be 3, 4, 5 processors. So it's really hard to do something code because it's really closed source and really dependent on a producer. But baseband is, this is the thing where we can actually make some changes. This is the user environment, yes, where its operating system in mobile phones or modern mobile phones is running. The baseband make charging management, yes, that bar blinking that is charging, everything is okay, and also the modem DSP management, the signal strength indicator is also there, and the time is showing on our display, and so on. So this is all, everything is done by baseband software, which is strictly connected to the CPU. After that we have DSP, which is digital signal processing, and there is really closed source GSM VCDMA stack inside. I think that changes or DSP software is really the most critical software in the mobile phone. So if you get some sources from the DSP or for the DSP, it's a really big issue, as the Osmocom, for example, open source baseband project get some sources and can make some their own DSP.
Has a DSP been fuzzed? Fuzzing a DSP.
Fuzzing?
Yes.
I don't know.
Fuzzing is sending random malicious data to the DSP and checking out what happens. Does it die? So you find vulnerability.
Oh yes. I know that talk.
I don't know what talk you're talking about.
For example, yes, there are some people around these projects for fuzzing and finding some vulnerabilities for the DSP, but it's really hard to know because the whole architecture is really closed and you cannot get some sources.
Yes, but that's why you need to fuzz it.
Yes, we can try it. Okay, I think there is some people around this.
But as far as I understand, even if you have that Nokia with Linux, the DSP part is
only binary, some piece of binary
not
code.
available open source.
It's not available, yes.
How many producers are there of DSP or baseband firmware?
There are a few, really few, maybe 3 or 4. I know that the Texas Instruments have his own, the MTK, which is some Chinese producer, and maybe the whole IRM or some on IRM basis, which can be licensed by some other producers. So they are not so much. They have, I think they have some similarities also. So maybe that fuzzing can be interesting.
I think it is very much. It will be really.
Yes, here we can see that package and package. It's a BGA component which can be stacked. Each layer is one processor, and this is really hard to solder. You can see that solder joints in these two are quite not so good. It's actually, they are not using solder balls anymore. They are using some polymer balls, which is plastic, some kind of plastic, and this is really high tech. It's not usable in I think in hobby like.
So this is
environment.
4 processors the CPUs.
Yes.
This is the DSP, the basement processor, and
Yes, it can be two DSPs and two processors and they can be connected each other. For example, one processor for the some like microcontroller unit, another processor for the operating system, one DSP for the GSM stack, and one DSP for the ECDMA stack. And you can stack it on each other, and now it looks like that. And now go and solder. Oh, it's impossible. It's impossible. So this is why I don't make some deep information about this, because it's not usable. Maybe from the software side we can fuse it, we can hack it from the software side, and we can imagine how it works. But if we want to build something on this, I think it's impossible nowadays. Yes. The RF part. RF part is also very interesting because it's a pure analog part. Yes, and it consists from the three parts. It's the front-end module. This ANEOS is the RF modulation and demodulation chip, and after demodulation it goes directly to the baseband. This is the RX part, which is receiving. The front-end module have some low noise amplifiers, some filters there, and after that it goes to the demodulator, which we have where we have some internal oscillators, and they are really internal. For example, we have in one processor or this demodulator, we have a local oscillator inside the package of the chip, which is oscillating on a 3.6 gigahertz, and it's really hard to measure if something goes wrong, because it's inside the package. You don't have any possibility to get to this. So the RF part is interesting. You can use this part, but you cannot measure anything. So you cannot make some reverse engineering or something like that, because also we have some, yes, we can etch the top of this demodulator part, yes, and we can slice it and analyze it and so on, like the micro cards, if someone knows what I'm talking about. But it's really hard work. Also, this is the same in the AX part. It's also the modulator, some filters to not make too much noise around of surrounding bands. We have front-end module which have a power amplifier, and from the power amplifier it goes directly to the antenna. So this is all. Thank you very much. If you have some question now, you have time. How much? Maybe 3 minutes.
5 to 10 minutes for any questions. Please do not hesitate.
Yes, of course.
Raise
Or if you
your hand and ask.
do you have any hardware of this here readily available to show us all the parts in line? Do you
Yes,
have-
yes.
do
I have some scrap mobile phones, so I will be hanging around.
Yes.
You can come to me and I will show you directly the ESD filters, some ANVATS light sensors, hard drive. I can show you mobile phone with hard drive inside, which is really funky, quite funky, because it's too old phone. And I can show you the accelerometer inside and so on. And also I have some old phones and new phones, so you can compare how the technology goes and so on. So feel free to contact me, and if you need maybe help with other hardware projects, I'm a more hardware related guy, so feel free to contact me.
I just want to say that we are planning to have GSM hacking presentation here, maybe in a few months. If you saw last presentation for Chaos Communication Congress about GSM hacking using Motorola C123 phone. So we have 8 of these phones, so I can bring them to Progress Bar, and it's the first mobile phone you can use for flashing and upgrading to completely open source firmware called Osmo Kubaba. It's a from scratch complete implementation of GSM stack. So you can use these kind of phones for full access to GSM network, and you can do very interesting fuzzy things, for example. So just check our schedule, program, and you will see. Okay, and now it's about 5 or 10 minutes just for coffee break. So we will be back at 3 p.m.